Hey UC Pros, Pasha here. I'm about to take you behind the scenes of configuring a SIP gateway with the SIP gateway config utility. I will explain what the different parameters do and how are they affected by the architecture. I'm going to show you how to keep the config clean and clear so you will be able to scale it, adapt it, and configure SIP gateways fast with no faults. With or without the SIP gateway config utility, this video is going to be packed with SIP gateway knowledge. This is going to be fascinating. Let's do this. Hey guys, welcome back. In case you didn't yet have the chance to download the SIP gateway config utility, just go to the description below and click on the link to get the latest version. Now, to take you behind the scenes, let's take a real-life scenario to work with. In this scenario, we have three CUCM servers, an iOS-based SIP gateway which has a PRI connection to the PSTN, and the iOS gateway will also serve as a transcoder and a conference bridge. We also have a SIP trunk between the CUCM and the SIP gateway, which we will discuss in details later, and two phones that are registered to the .12 CUCM. One more thing before we deep dive into the config and the theory behind it. Currently, the SIP gateway config utility requires some things to be pre-configured on the router. That would be an IP address, basic IP routing setup for basic connectivity, and the serial interface up and running, with commands that would include card type, network log for the serial interface, and both the controller and the serial interface setup. You can check the links in the config notes to show you exactly how to do that. Alright, let's get to work and see what the SIP gateway config utility is all about. Let's start with the CUCM facing interface. What is it and why is it important? By default, the iOS SIP gateway will send the SIP packet with the IP address of the interface the packet came out of. Since IP routing can be dynamic, this could have very bad effect on voice applications. Let's take a look at this example. We have the SIP trunk on CUCM set up with the IP address of 192.168.0.224. But if the SIP invite from the SIP iOS gateway comes out of the interface 192.168.1.224 because of an IP routing decision, CUCM will be very disappointed with us. So disappointed that it would just drop our packet. Why? Because this IP address is not associated with any SIP trunk on the CUCM itself. It doesn't know this IP address. So, two rules of thumb here for configuring this in the config utility. 1. Use the closest interface to the CUCM. 2. It has to be the same interface with the IP address that is configured in the CUCM SIP trunk. This IP address. Now, let me show you how it looks in the config utility. So, what we have here is the bind all source interface giga 0/0.1. The bind all means bind media traffic and signaling traffic to this source interface. It means that all of the traffic, all of the SIP traffic and RTP traffic that's gonna go out from this SIP iOS gateway is gonna go through this interface. It also means that when this interface is down, we are in a big problem because our SIP messages are now facing an issue. That is why On routers with a lot of interfaces, UC professionals usually bind this SIP media and signaling to a loopback interface, which by definition is always up. Next, we have the fax protocol. Basically, you will have to decide whether you will use the T38 protocol, pass-through method, or both. If you do choose T38, keep in mind that this method will have to be supported end-to-end. So if you have VGs, they will have to be enabled for T38 as well for this to work. Now it's time to select our car type, whether it's gonna be E1 or T1, and then the slot it's connected to. You should use the same syntax here as you would use in the CLI itself. Now let's talk about the CUCM section. The CUCMs are ordered by priority. Now, this priority and these IP addresses should match the CUCMs in the CCM group that is configured for our SIP trunk. Let's see how we get to that. First, let's take a look on our SIP trunk. The device pool of our SIP trunk is HQ. For HQ, the CUCM group is HQ-CCM group. HQ-CCM group contains the server 10 and 11 by this specific order, and these are the CUCM nodes that we should go ahead and fill in the utility right over here. These are the CUCMs that are going to send the SIP messages to our SIP gateway and receive SIP messages from the SIP gateway. Now consider this. Our phone is registered to CUCM.12, which, as we saw, is not part of the CCM group of our SIP trunk. That means that the SIP request to the SIP gateway will go out of a CUCM that is part of the trunk CUCM group, which is either 10 or 11, unless we have the run on all active CUCM nodes checked on the trunk. Let's see how this looks in CUCM itself. So we go to the trunk, and here we go, run on all active unified CM nodes. This is the exact parameter which we have here, right? So we do have it checked. What that means is that for the same scenario as before, when our phone calls the PSTN via the .12 CUCM node, the invite to the SIP gateway will go out of the same .12 CUCM node. And this is fantastic because it reduces unnecessary backlink communication between the CUCM nodes. But this requires some very interesting config on our SIP gateway. Now, before I show you the config, I just want to quickly show you the dial peers high-level architecture that we use to make the config clean, scalable, and adaptable. Let's begin with dial peer 1. Dial peer 1 is used to match incoming calls from PSTN. We do that using the incoming call number command. Dial peer 2 is used to match all of the traffic that is coming from all of our CUCM nodes in the cluster. And I'll show you how it's done really soon. Dial peer 10 is used for all of the outgoing calls to the CUCM. And dial peer 20 onwards is responsible for all of the traffic to the PSTN and the number of dial pairs is actually directly related to the country's dial plan. Now let's dive a bit deeper. First of all, let's look at what happens with the CUCMs that are part of the CUCM group used by our trunk. First, they are going to the voice class URI1 SIP. The voice class URI1 SIP is assigned to an incoming dial pair from our CUCMs. This one, incoming URI via 1. Now, this dial pair is the one that we want to be matched for all of the incoming requests from our CUCM cluster. We use the incoming URI via command, which matches the via header in the SIP request, which in CUCM's case will always be the IP address of the CUCM that sent the request. And this is also why we would put all of our CUCM nodes for the cluster in this voice class URI when run on all active nodes is checked. So whenever I add a CUCM that is not part of the trunk CCM group, I would add it to the voice class SIP URI. Another place we use the prioritized CUCMs is for the voice class server group. This server group is used for the outbound calls towards CUCM and is assigned to dial pair voice 10. This dial pair is matched by the destination pattern, which we will get to later, but when this destination pattern is matched, the SIP request goes to the prioritized server in the voice class server group. And we want to keep this clean, so we would only use the CUCMs from our trunk CUCM group. By doing that, we cover all of the requests toward the CUCM cluster with one elegant dial pair. Now let's see where those additional CUCMs meet us. First of all, as I mentioned, we will see them in the voice class URI, which matches incoming calls from any node in the CUCM cluster. That is how we use one dial pair to cover all incoming VoIP messages from a cluster, which is very cool if you ask me. Another place the additional CUCMs are required is the IP address trusted list, and this is crucial because if we don't add those servers here, any request that is coming from these servers will be blocked. Why? Because by default, any IP address that is not specifically configured on a dial pair as a session target or as a session server group will be blocked as a security measure. And since our trunks CUCMs are in the server group, all additional CUCMs must be set up in the IP address trusted list individually. The next section defines the media parameters for our SIP gateway. First of all, the codec preference. This section will define which codecs will the SIP gateway support and prioritize for the VoIP calls towards CUCM. Now, these are the most used codecs which CUCM and Cisco phones like and use mostly. Eventually, these will be negotiated by what is configured in CUCM's regions for every call. So make sure that if you have multiple regions with low bitrate codec between them, like G729, make sure you make it available for the gateway in this section. All of the selected codecs are placed in the voice class codec 1, which in turn is assigned to our VoIP dial pairs. In terms of DTMF methods, well, we can actually discuss this for hours, and we do discuss this in the SIP troubleshooting course. But the bottom line is that SIP KPML, which is out of band, and RTP NTE, which defined by RFC 2833 and carried in an RTP stream, are the recommended methods to use. The selected DTMF methods are then applied to all of our VoIP dial pairs. Next, we have the SCCP configuration of optional media resources, which include a transcoder and a conference bridge. The CUCMs here are the ones that are configured on the CCM group of these media resources, and this is crucial, otherwise your media resources won't register properly. So go to your media resource and verify which CUCM servers are part of its device pool CUCM group. First, let's go to the conference bridge, find this is my conference bridge, and the device pool is HQ, which basically we already know which CUCMs are part of it, right? So the CUCM group is HQ CCM group, and these are the servers that we are going to use in our config tool. Now, for the transcoder and the conference bridge, this is what we do on the gateway. First, we configure the DSP farm, then we create the DSP farm profile. This one is for the conference bridge, and this one is for the transcoder. So we assign the codecs, we define the number of sessions, we configure the CUCM servers in all of the relevant places, and we associate the DSP profiles with a name it will try to register with. Now you can play and edit these names after you're done with the tool and copy the config to a notepad. Just make sure that you configure the same name here and on the media resource in CUCM itself. Right? This name here. So one more thing before we get to the dial plan part. SIP parameters, namely SIP options ping and retry count. I wrote about that part in depth in one of my posts, so do check the description below for the link. In this post, we discuss both the config on the CUCM trunk side and the config on the iOS side, which affects the fallback and the redundancy mechanisms. And this is super important stuff. Please take a minute to go over it. This is the stuff that makes you a pro. And this is configured on the SIP iOS gateway in two stages. First, the voice class SIP options keep alive 1. This is a SIP options profile, and it uses the defaults of up interval 30, down interval 60, and retry count of 5, which should be good unless you have some special requirements. And once again, you can go over the post to see how to configure and how to change that from its defaults. Now, once the SIP options profile is configured, we'll be applying it to the outgoing VoIP dial pair towards CUCM. What this profile is going to do is it's going to send keep alives over SIP protocol to all of the nodes in the server group. And basically, once one of them is down, it's just going to skip it. This config makes it nice and clean. There is no need to create dozens of dial pairs which no one knows what they do after 2 weeks. And this brings us straight to the dial plan section. The first parameter we are going to use is the DID range. The range that we are going to enter here must match the amount of digits that we receive from the PSTN on the E1T1 interface. In this case, we might want to use the debug-SDN Q931 to see exactly which digits are being forwarded by the PSTN service provider to our gateway. The prefix digit. If you are using one and you don't remove it in CUCM, this is where you mention that. If you do remove it in CUCM, like in the route pattern or the route list or the trunk itself, using a discard digit pre-dot function for example, leave this field blank. From here on, feel free to configure your local country dial plan in the dial pairs based on the example below. You can also use the previously mentioned post that would help you with that. For example, use the prefix digits when you need to restore digits that the gateway dropped because of a strict match, like in dial pair 22 for example. In this case, since 9011 is matched explicitly, these digits are dropped. Do note that this is true for POTS dial pairs only. Now, since our PSTN provider expects to receive an international prefix code, we need to complete that with the said prefix command. This is it, you are good to go. Just copy the config on the right and paste it in your gateway. I hope this video helped you understand how SIP gateways operate, their different configs and parameters, and how you can use the SIP gateway config utility to quickly get a working, reusable advanced configuration. I truly hope this has been informative. Let me know in the comments below if I missed anything, or if you want me to deep dive on a specific subject, or even if you have a feature request for the utility. Go ahead and leave a comment. Thank you for watching.